Hello, in this course we are going to use springai to integrate with OpenAI API. The OpenAI API gives you access to powerful AI models like GPT-3, GPT-4, GPT Vision or any other OpenAI model, allowing your applications to interact with these models using simple HTTP requests. So first we need to obtain an API key from OpenAI. To obtain your key, go to OpenAI platform website, which is platformopenai.com. Then log in or create new account if you don't have one. I will just log in with Google. After you log in, then click on Dashboard on top right side. Then navigate to API keys via the menu on the left side. Here click Create New Secret Key. Here choose Default Project, give all permissions, and click Create Secret Key. Now you click Copy and save your API key to a secure location. Remember that once you click Done, you will not be able to see the key again. To get started with this section, you can download my project from GitHub using the link provided in the resources. But if you prefer to build it from scratch, I will walk you through how to create a new Spring project. And to create new Spring project, we go to Spring Initializer, which is startspring.io. Here I choose Java, Maven, the latest version of Spring Boot, and as a group I'm going to use my name and surname. Artifact is gonna be springai OpenAI. Packaging is jar, Java 21, and as a dependencies we need to add OpenAI, this one. Also I need Spring Web, and I will use Lombok. Next you click Generate. You need to unzip this file and open folder in the IntelliJ or whatever IDE you prefer. Okay, I opened my project in IntelliJ. Let's have a look at what we have. So we have some application class here with main. We can try to run it. And it fails because there is no OpenAI API key, and that's something we are going to set in the next video. In this video, we are going to make simple integration with OpenAI API using springai. Actually, springai makes it pretty easy to integrate with any API. You will see that it won't take us more than 50 lines of code. First thing we need to do is set up OpenAI API key with the Spring property. This key will be used by Spring to connect to OpenAI API. So we go to Application Properties, and here we need to put springai OpenAI API key. And it would be very bad practice to put key directly here. So we are going to use environment variables. Here I will define environment variable name, OpenAI API key. And then we go here, edit configurations. In modify options, you should enable environment variables. Then click here, plus, put OpenAI API key as a name and your key as a value. Click OK, OK, and run application again. Now you can see that the application is started. It means that OpenAI API key is valid. Now we want to send request to the AI model. We want to ask some questions and get some answers. So let's create simple DTOs for question and answer. I go here, create DTO package. Here I will create question. It's gonna be record. We need only string value for question. Also we need to create answer. It's gonna be record. And we need string answer. Now let's create OpenAI service. This service will be used to send a request to the OpenAI model and receive a response. So I will create new package service and inside create Java class OpenAI service. Let's mark it as service bean, and to send a request we need something called ChatClient. And we need constructor to initialize client. We will use ChatClient.builder to build our client. So we say this client equal to builder.build. Next, we need to create some method that will return answer. Let's call it getAnswer. As a parameter, we need question. And here what we need to do is to call client.prompt.user. Put here question.question. And call. Now from call response spec object we can get content, and that's the response from AI. We simply return new answer with content. Okay, now let's create controller to call this service. So I create package controller. Here create OpenAI controller. mark it as REST controller. To initialize beans, I will use required args constructor from Lombok. Here I need private final OpenAI service, and we create the same method that returns answer, get answer. We need question. Question should be request body, and here we return OpenAI service get answer by question. We also need to mark it as post mapping and put some URL to call this endpoint here. Let's run the application, and to send HTTP request I will use postman. So here I create new request, it will be post, we will send request to localhost 8080 ask. Then go to the body, row JSON, and here I need to put some question. Let's say, who are you? Send the request, and we got a response from AI. It says, I'm an AI language model created by OpenAI, designed to assist with a wide range of questions and tasks by providing information and generating text-based responses. So that's how you can easily integrate with OpenAI using springai. What's interesting here is that call doesn't really call anything. If you go inside in the implementation, you can see that it only creates new object of default call response spec. And the actual API call happens when we call method content. If we go here, inside method content, we have method doGetChatResponse. Go inside. Here again we have doGetChatResponse. So inside this doGetChatResponse method, we can find the chat model called here. And chat model is something used to send a real HTTP request to AI model. Let me show you how this structure works. So ChatClient is a wrapper for chat model. It gives you fluent API communication with an AI model and a few more features that we will discuss later. Chat model is the component that connects your app to AI models from various providers depending on implementation. Chat model is implemented depending on what model you want to use. Some examples are OpenAI chat model, Azure OpenAI chat model, Amazon Bedrock chat model, and Video chat model. There are around 20 implementations right now. You can find them in springai docs. So we give a question to ChatClient. ChatClient uses chat model to send a request to the AI model. The AI model processes it and sends the response back through chat model. Then ChatClient delivers the response to us. Okay, that's it for the first integration. See you in the next video. Hello, in this video we are going to talk about prompts and messages. Okay, let's have a look at prompt method. As you can see, it can accept something called prompt. According to springai, prompts are inputs that guide an AI model to generate specific outputs. The prompt class functions as a container for a series of message objects and request chat options. In the AI context, a prompt is text or instructions you give to an AI model to guide it on what response or output you want. So if we simplify it, a prompt is like your question to the AI. So let's create method getAnswer with prompt. I will simply copy this one, rename it to getAnswer with prompt, and here we create simple prompt. New prompt, and the prompt constructor can accept a string as a parameter. So we put here question.question. Now let's add prompt here. We don't need user anymore, and it returns call prompt response spec. Okay, let's also create the same method in controller. Let's go here. I'm gonna copy this, say getAnswer with prompt, call here getAnswer with prompt, and add prompt to the URI. Okay, so here we simply create prompt, pass it as a parameter, get some content, and return it. Let's run the application. And to call our new endpoint, I'm going to create new tab here, add prompt. Let's put some body. We can actually copy it from previous request. Okay, and let's send it. Okay, we get an answer. Now let's take a look at how the prompt constructor works inside. As you can see, prompt creates a new user message when we pass string as a parameter. Let's have a look at what is the message. According to springai documentation, message is an interface that encapsulates a prompt textual content, a collection of metadata attributes, and a categorization known as message type. Okay, so as you can see here, we also have constructor with message, list of messages, some chat options. Let's go and use one of those. So we simply can create message here. And let's create user message, question. Okay, and now we can pass message. Let's rerun the application and check that it works fine. Okay, send a request. And it works. Okay, let's have a look at message. It has method getMessageType that returns message type, and also methods from content, like getContent and getMetadata. So message is an interface and it has few implementations. First one is an abstract message. This implementation overrides all those methods, including getMessageType. So it returns this message type, and message type is specified by extensions of abstract message. Let's have a look at extensions. So we have 4 extensions: user message, system message, assistant message, and tool response message. And if you go to, for example, user message, we can see that it calls superconstructor with message type.user, and this message type is set to abstract message. So let's have a look at all message type we have. We have user, assistant, system, and tool message types. So let's have a look at their difference. So first we have user message. It represents the user's input, their questions, commands, or statements to the AI. This role is fundamental as it forms the basis of the AI's response. So basically, user message represents a simple question to the AI from the user. Next one is system message. So system message guides the AI's behavior and response style, setting parameters or rules for how the AI replies to the input. It's akin to providing instructions to the AI before initiating a conversation. Next one is tool response message. It focuses on returning additional information in response, and it connected with functions, which is a separate topic, and we will have a look at it in one of the following videos. Next one is assistant message. It's the AI's response to the user input. Assistant message is used to let the AI know that the content was generated as a response to user. So by default, AI models do not remember previous requests and response. So to create something like a chat, we have to send a full history to AI for each request. Okay, let's use system message. So what I'm going to do is to create new message, system message, new system message, and it's used to guide the AI's behavior. So let's say respond in one word. Okay, and we want to add it to prompt, so we need to use list here, pass message with system message. Oh, let's rename it and rerun the application. Okay, now I send the request, and as you can see, it responds in one word only. When I asked who are you, it responds assistant. System message also used to guide AI with response style. So let's add something like wrap response with response tag. Okay, let's try this. Rerun the application, send a question, and as you can see, response is wrapped with response tag. Okay, next one is assistant message, and to understand how assistant message looks, let's call not content but chat response here. Okay, this one I remove, and we will return chat response result output get content. Okay, let's put debug point here and rerun application with debug. Send a request. So let's go to IntelliJ and see what we have in chat response. Here we have generations. Generations is a list because some models have the option to generate more than one answer. In our case, we have only one response, and it consists of assistant message and chat generation metadata. So as you can see, assistant message is an object of class assistant message, and it consists of message type, metadata, and text content, which is a response from the AI. In chat response, we also have chat response metadata. Chat response metadata contains usage. Usage shows us completion tokens, prompt tokens, and total tokens. Prompt tokens are the number of tokens in the input prompt you sent. Completion tokens are the tokens generated in the AI's response, and total tokens is the combined total of both. Tokens are building blocks of how an AI model works. On input, models convert words to tokens. On output, they convert tokens back to words. And we will be charged based on the total number of tokens used. Okay, now let's go back to this method. Here we actually already used a prompt with user message, which is here. So if you have a look at user method implementation, this will set user text, which is used later in doGetChat response here. So we have processed user text here and create new user message from this processed user text. Then this user message added to list of messages. And later these messages are used to create prompt and send it to chat model. Also, if we have a look at messages, we can find that in the messages we add system message, which is created here using system text. So how you can set system text is by using .system method, like respond in 3 words. Okay. Let's rerun the application and have a look at what is sent to the AI. I will put a breakpoint here before we send in prompt to the AI and send a request to ask endpoint. So inside the prompt we have 2 messages. First one is system message, second one is user message. System message is what we set right here in .system respond in 3 words. As you can see, system message text content is respond in 3 words, and user message is what we have sent here in question. So let's send it and see what we get in response is AI language model. So it responds in 3 words. Okay, now let's change our springai schema according to what we have learned. So request is changed to prompt. A prompt is made up of list of messages along with chat options, which are basically settings that I will explain in more detail in one of the next videos. And response is changed to chat response that consists of generations, which include the output and some metadata, as well as response metadata. Okay, we have covered some important concepts about prompts and messages in this session. See you in the next video. Hello, in today's video I want to show you something called prompt template. Prompt template class is a component for prompt templating in springai. This class uses the open source Spring template engine for constructing and managing prompts. Okay, let's create prompt template. New prompt template, and prompt template constructor can accept a string as a parameter. So let's just use it. Question.question. Then we can create prompt using method create. So it's like prompt from template. Yeah, but what if we want to create not prompt but message instead? So for this purpose we have create message method. And this will be message from template. Okay, but what kind of message is this? Let's have a look. As you can see inside create message, user message is created. And the same happens when we use method create, because we create new prompt here and new prompt creates user message inside. So this will create us prompt with user message and this create us user message. What we also have is system prompt template. System prompt template, new system prompt template. It also can accept a string as a parameter. Yeah, and we can put any string here. So basically it works the same way as prompt template, but creates system message instead of user message. Just to remind you, system message is used to guide the AI's behavior and response style. So we can say here respond in one word. Yeah, and then create prompt using this prompt template. It's system prompt. The same way from system prompt template, we can create message. And it will be system message from prompt. Yeah, let's have a look at create message here. You can see that new system message is created. And when we have a look at create, here new system message also created. Okay, I think it's pretty clear. Now let's have a look at another constructor, and it can accept resource as a parameter. And that's really useful because you don't want to have to go through the project and find out where you can change that system prompt string. And this string can also be huge, so it's much better to have a file in the resources that's easy to find and change. And we can use something called string templates files for such cases. So let's create new folder here, call it prompts. And inside I will create file system message.st. st means string template. Okay, and we put here our system message, which is respond in one word. Then we go back to the service and let's use this file. So Spring allows us to import this resource. Let's call it system resource using value annotation. So we need class paths, prompts, and system message.st. Okay, now let's use this system resource here and create message from system prompt template. System prompt template message and use here. So we don't need anymore this system message. Let's just remove it and rerun the application. Now we go here to ask prompt endpoint, send a request and get a response in one word, which means string template works. Also, when we call method create message, we have something called model here. So model is a map where keys are placeholders for names in the prompt templates and values are the dynamic content to be inserted. So let me show an example. We go to system message and I'm going to paste here my prompt, which saying you are helpful AI assistant that helps people find information. Your name is name, which is parameter, and you should reply to user's request with your name and also in the style of a voice, which is also parameter. So here we can create some map with string as a key, object as a value, call it model, and let's say it will be hash map, import, and we put to the model key name with value, let's say Alice, and put voice of let's say wizard. So now we can use this model to create message, and this message should contain this name and voice together with prompt. So let's run the application and we go back to Postman to test it and send request to ask prompt. Let's send it. Okay, and what we get is greetings traveler. I am Alice, your humble AI assistant and guide in this vast realm of knowledge. How may I assist you on your question today? So as you can see, it works, and you also can play with voices or any other parameters to see how it works. Okay, we have learned prompt template in this session. See you in the next video. Hello, in this video I'm going to show you how to format AI responses. Okay, let's say we want to generate the filmography for an actor. What we can do is change user message, for example, to this one. Generate the filmography for an actor, and we need to pass some parameter here. Okay, and to pass parameter we can use method with consumer prompt user spec, which allows us to set some parameters. So what we have to call is method param, and as actor we are going to pass some actor. Yeah, so the method will accept actor as a parameter. And we also don't need this method anymore, so we can remove it, remove imports. We should rename the method to get actor films, and we go to OpenAI controller, remove unused method, rename this method, and what I'm going to do is to change this to get mapping with actor films pass, and we don't need request body anymore. What we really need is request parameter, and pass this request parameter directly to our service. So let's rerun the application. Okay, go to the Postman, put here my URL, and as a parameter you can pass actor. Let's say Tom Hanks. Send the request. Let's wait for the response. And as you can see, we get some data. It's really hard to read and process such data in the front end. That's why we want the response to follow specific format. Well, I want this API to return JSON with string actor name and a list of string with movies. So let's create a record class for this. Actor films. What we need is actor name and a list of string voice. Need to import list and change the answer to actor films. We also don't need question anymore, so I'm going to remove it. And let's go back to the service. So springai gives us a very convenient way to format response from AI to custom DTO. We just need to call the method entity with class as a parameter. So dot entity, and here we have to put class. So actor films dot class, and it will return us actor films. Now I can use actor films to put it into response. Let's rerun the application. Go back to the Postman and send request again. And as you can see, it returns perfect JSON with actor and its movies. But how does an AI model know what to return? So let me show you. If we go to the service and go inside entity method, we can see that BeanOutputConverter created here. It used in doSingle with BeanOutputConverter. Go here. So you can see that do get chat response called here with structured output converter dot get format. Let's go into get format method, and there are three implementations: BeanOutputConverter, ListOutputConverter, and MapOutputConverter. So as we use BeanOutputConverter there, we should go here. What we see here is this template that is used to instruct AI how to respond. So it says your response should be in JSON format. Do not include any explanations. Provide only compliant JSON response. following this format without deviation. Do not include markdown code blocks in your response. Here is the JSON schema instance your output must adhere to. And as you can see, it uses JSON schema. By providing this JSON schema to the AI model, it understands what exactly we want in the response and returns the response in required format. Okay, and if we go back to this method, we can see that Spring maps JSON from the AI model to our entity using convert method. Let's go inside convert method of BeanOutputConverter. And here it simply uses object mapper. Okay, go back to the service. And here we also can use entity method with parameterized type reference to return values with generics, such as list. If you want to return, for example, list of actor films, then what you need to do is create new parameterized type reference and simply put here a list of actor films. Okay, and put it here. So this structure will return you a list of actor films. Okay, but we don't need it, so I simply remove it. And entity also provides method versions that accept output converters. So we can create our bean output converter manually. Let's do that. Bean output converter, a new bean output converter. What we need to do is pass actorFilms.class here. Generic would be actor films, and we pass bean output converter here. Now, if we run the application, it should work the same way as it worked before. Okay, let's call the API, and as you can see, it works. And also, you can use list output converter or map output converter if you want to convert your response to a list or map. So inside the list, you can see that format that's sent to AI looks like your response should be a list of comma separated values with example. And let's go and check map converter. It says your response should be in JSON format. Data structure for JSON looks like this. And then this JSON simply mapped to hash map. Great. Now let's change our springai schema according to what we have learned. So we have input converter and output converters now. The input converter adds specific instructions to guide the AI on how to format the response. And the output converter uses object mapper to transform the JSON response into our DTO class. Great, we have covered output converters and learned how they work. See you in the next video. Hello, in this video I'm going to show you some ChatClient capabilities that might be useful for you. And the first thing I want to start with is default advisors. So Builder allows us to set some default advisors. And advisors allow modification of data used in the request or response. And to create advisor, we need to implement request response advisor. I want to create some kind of custom logger, so let's create new class for this purpose. Gonna be logger advisor. And we have to implement request response advisor. Okay, we can override some methods like advise request and advise response. Here we will just return request, we will not change it, as well as here we will not change response, but you can change both request and response if you want. So what I want to do is to log something here. Let's say I want to see the model I sent request to and user text with system text. So I'm going to get request ChatOptions model. Next thing I want to is user text. And system text. Okay, to log it, I'm going to use slf4j from Lombok and simply put log info and let it be request to some model, and I put model. Also, I wanna log user text. And system text. Okay. And for response, let's say I want to log some metadata like response get metadata. Response metadata, and put metadata here. And to add our logger advisor, I go to OpenAI service and put new advisor here. Let's run the application. Go to the Postman, send our request, and in logs, I can see that request is sent to GPT-4o model, user text, system text, and I can see some response metadata here, is token usage, and so on. Okay, now you see that we use the default model, which is GPT-4o, but what if I want to change it? And that's where we can use default options. So I'm going to use default options. As you can see, it accepts ChatOptions, and there is default implementation for ChatOptions, which is default ChatOptions. It has some parameters here, but we have specific one for OpenAI, which has much more options. So the option I need is model. So what I'm going to do is use OpenAI ChatOptions.builder.build and put here with model. And I can choose it from chat model dot, and you can see here the list of available models. So let's say 3.5 turbo, and rerun the application. Now send request, and you can see that request is sent to GPT 3.5 turbo model, which means the model was changed successfully. What we also can set to ChatClient is default user and default system, which are just default user message and system message. So we simply put default user and put some user text, and default system with system text. Also, we can set default functions, and functions are separate topics, so I will tell you about them in the next video. Now let's go back to default options, because there are more options, and let's have a look at them. So model is just changes model, we already did use it. Next one is frequency penalty, and it is a setting that controls how much the AI model should avoid repeating the same words or phrases. A positive value means that model will be less likely to reuse words already used, and it helps to make the response more varied. Next one is logit bias. This setting allows you to adjust the likelihood of specific words or tokens appearing in the AI's response. And you provide a JSON object mapping token IDs to bias values from -100 to 100. A higher bias increases the chance of token being selected, while lower bias reduces it. And to understand this, we need to understand what a token ID is. So let's go to platform OpenAI tokenizer and use some examples. So if I put hello world here, I can see tokens, and if I click tokens ID, I will see IDs of each token. So 9906 is ID of hello, 1917 is ID of world, and so on. So to exclude the token hello, I need to put its ID, which is 9906, to logit bias map as a key, and value should be -100. But if I want to use the word hello more often, then I should put the into logit bias key 9906 and positive value from 1 to 100. So here I have an example. Let's say we have such logit bias map, key 9906 and value -100. This will completely prevent the token with ID 9906 from being selected. Next one is 1907 with value 50. It increases the likelihood of the token with ID 1907 being selected. And the next one is 0 with value -50, and this decreases the likelihood of the token with ID 0 being selected. Okay, next one is log props. This setting determines if the model should return the log probabilities of each word or token, and if it's set to true, the output will include the log probabilities along with the text, showing how confident the model was in choosing each word. Next one is top log props. This setting specifies how many of the likely tokens, up to 5, you want the model to return for each word or token position in the response, along with their log probabilities. This lets you see the top choices the model considered at each step. Next one is max tokens. This setting specifies the maximum number of tokens the model is allowed to generate in its response. If you set max tokens to 50, the model will generate up to 50 tokens in its response. Next one is N, and this setting specifies how many different response options the model should generate for each input. If you set N to 3, the model will generate 3 different responses to your input. But you should remember that each generated option will use tokens, so generating multiple options will increase the number of tokens used and therefore the cost. Next one is presence penalty. This setting is a value between -2 and 2, and that tells model to introduce new topics in its response. Basically, presence penalty is the same as frequency penalty, but it applies to topics or ideas instead of words or phrases. Next one is response format. This setting allows you to specify the format in which the model should output its response. It works the same way as the entity method that we already used. Next one is seed. This setting allows you to specify a value that the model uses to try to generate consistent response for the same input across repeated requests. So if you set a seed, the model will attempt to produce the same output each time when you have identical parameters and input. However, this behavior isn't better and determinism is not guaranteed. Next one is stop. This setting allows you to specify up to 4 sequences of text that, when encountered, will cause the model to stop generating further tokens. So if you set stop to end, the model will stop generating text when it encounters the word end in the response. In this case, as soon as the model generates the word end, it will stop generating any text. Next one is temperature. This setting controls the randomness of the model's input during text generation. It is value between 0 and 1, and higher temperature like 0.8 makes the output more random, creative and diverse, and the model will take more risks, leading to less predictable responses. And the lower temperature like 0.2 makes the output more focused and precise, and model will be more conservative, sticking closely to the most likely choices. Next one is top P. It's similar to temperature in that it controls the randomness of the model's output, but it just works in a different way. So instead of adjusting the randomness across all potential outputs like temperature does, top P limits the model to consider only most likely tokens. And to determine the most likely tokens, it uses probability mass. For example, if top P is set to 0.1, the model will only consider the tokens that make up the top 10% of the total probability distribution. This can make the output more focused and prevent the model from choosing less likely and potentially more random tokens. Next one is tools. This setting allows you to provide a list of functions that the model can call during its operation, and the model can use these functions by generating the necessary JSON inputs to invoke them. So currently only functions are supported as tools, meaning the model can perform specific tasks by calling these predefined functions. And we will discuss functions later, and I will show you an example on how to use them. So now let's continue with other options. Next one is tool choice. This setting determines how the AI model decides whether to call a function or generate a message in response to an input. So if tool choice is none, the model will not call any function and will only generate message. If the tool choice is auto, the model can choose between generating a message or calling a function, depending on what it deems most appropriate. Also, you can force the model to call a particular function by specifying it in specific format with function name. By default, if no functions are available, the model uses none, and if functions are available, it uses auto. And that tool choice builder can help us create tool choice object to set this behavior. Next one is user. This parameter is like a unique tag that represents the person interacting with AI. It helps OpenAI keep track of who is using the system, which is important for monitoring usage and spotting potential issues. Think of it as a way to keep an eye on things without knowing exactly who the person is. Next is function callbacks and functions. And functions allows you to specify a list of functions by name that the model can call during a chat completion request. These functions need to be pre-registered in function callbacks. So if you set them with default options, they stay enabled for all chat requests. And this I will explain in the next video. Also, all these options can be configured in two ways, at a startup or at runtime. So to configure it at startup, use chat model to set default options here. And to configure it at runtime, we have two different ways to do that. So first one is to create prompt, new prompt. So you put here your content, and as a second parameter, you can put chat options like OpenAI chat options, builder build, and put any options here you want. Or if you don't use prompt, you can use method called options here and put your OpenAI options or any other options in this method. Runtime options have highest priority, which means that if there are non-empty runtime options, they will override the startup options. Okay, now let's change our springai schema according to what we have learned. So now we know that chat options can be configured at startup during chat model initialization or at runtime with each request. And these options are merged and used to create the request sent to the AI. Again, runtime options have highest priority, so it means that if there is non-empty runtime options, they will override startup options. Okay, we have covered ChatClient and chat options here. See you in the next video. Function calling in OpenAI allows the AI to interact with predefined functions, meaning it can do more than just generate text. It can actually perform tasks like looking up for information, doing calculations, or interacting with external APIs. So you define these functions and the AI can call them during a conversation to get specific results. And let's have a look at simple schema. Here we have application and AI model. Application sends prompt with function information, and the AI model decides based on prompt if function can help it with providing valid response. If not, it will just generate and send response back to our application. But if yes, it will first respond us with function name to call. Then application calls the function, and function can basically do anything. For example, do database call, external API call, or do some calculations. And it's really useful when you want to provide some live information to the AI, like current weather or some data from your database. So then function sends some data to the application, and this data together with prompt sent to AI again, and AI model sends response based on this data. So the key point here is that AI model itself decides whether or not to call a function and also chooses which function to use. This means we don't need to always trigger these functions or send extra data to the AI model, which helps save tokens and speed up the application. So let's say sometimes we want to force AI to use our own data. And continuing our example with actors and movies, we can write a function that will return certain movies that we won't always include in the response for certain actors. And springai provides easy way to configure these functions. All we have to do is create a bean with a name equal to the function name. So I'm going to create some config package with configuration class. Let's call it config. Mark as configuration. And now what we have to do is to create a bean. This bean is going to be a function, and it accepts actor films and returns a list of films for some actor. Let's call it the getActorFilms. Okay, and as a data source, I'm going to use simple map here. So what I will do is create a map with key as a actor name and value as actor films that we want to include. So it's gonna be films by actor. And I'm going to use map of, and I will just paste some examples that I have. So for Tom Hanks, we are going to return these three films: A Man Called Otto, Pinocchio, and Finch. And for Leonardo DiCaprio, we are going to always return these two films. So what we need to do is to create some implementation here. It's going to get from films by actor, actor films by actor name. Okay, it needs to be a bean, and to let function know when to call this function and how to use this data, we need to add description from Spring Framework context annotation. So I have prepared description. It says that function get actor films by actor name, and some description for AI that if the function returns an empty response or null, provide your own data, and if function returns less than 10 films, you need to add your own data. So this description is going to work as instruction to the AI on how to use our function. Now we go to OpenAI service and add a function using default options. We simply call this function here and provide function name, which is getActorFilms. We actually also can provide this function during call here. Then this function is going to be not default, but used only for this method, but it doesn't matter for us. Okay, now let's run the application and see how it works. So I sent Tom Hanks, and as you can see, 3 films that we mentioned in our function are in response, and AI added 7 more to make it 10. So if I send request again, then we're going to see our 3 films again and some new films from OpenAI. So we also can test it with Leo, put it here, send the request, and in response we have our 2 films and some that were generated by OpenAI. And we can also try to generate with someone not in our list. Let's say Uma Thurman, and send a request. So it simply generates some random films. Now I want to show you what exactly happens with all this function calling stuff. I rerun the application in debug and put few debug points. Let's send a request. So here we can see chat request, and we have our user message with text that asks to generate filmography for an actor and says which response format AI should use. And also we have tools, and as you can see, this tool has type function, and the function has description, name, and parameters. So using this information, OpenAI model can understand that it can call function and get some data. Okay, let request go. Here we get the response, and the response consists of body with choices. So you can see finish reason is tool calls, which means that tool was called by OpenAI model. So we are going to check message. It has role assistant and it doesn't have any message, any raw content, but it has tool call. So if you go inside tool call, we can see function here, and we have function name with arguments. So all we need as argument is actor name. And using this information, springai will understand which function to call and with what parameters. Next, springai calls our getActorFilms function. So this function will return list of movies for actor. After that, request to AI sent again, now with 3 messages. So first one is initial request that says generate filmography for an actor, which is user message. Second one is assistant message. This one was sent from AI to us to call the function. And third one is a tool message with raw text as a result of function calling. And we have to send first 2 messages again because the OpenAI model does not remember any conversation history. So I just let it go and we get a response. Now let's summarize all this with schema. Here is the AI model, and the first request is sent to the AI model. It consists of first message with role user and user question and function definition with name, description, and parameters. Then the AI model decides to call the function, so it sends a message with role assistant, function name, and parameters for the function. So then the function is called, and a second request is sent to the AI. It consists of full history with 3 messages, user question, assistant message to call function, and function response inside a message with role tool. And in the end, AI generates a response based on user question and function data and sends it back to the user. So we have learned how to use function calling to make your AI interactions smarter and more dynamic with OpenAI and springai. And see you in the next section where we are going to talk about prompt engineering. Hey guys, thank you for watching this video. I hope you liked it. Let me know in the comments. Also, if you want to see a continuation where I build a calorie counter application API and talk about basics of prompt engineering, image speed generation, image recognition, RAG, similarity search algorithm, and vector databases, you can follow the link in the description. Again, thank you for watching and see you later.